What if the universe decided to put on its greatest show in decades, all in one single year? 2025 is not just another trip around the sun. This year carries something extraordinary, a cosmic alignment of events so rare that astronomers have been marking their calendars for years. Multiple planets will dance into perfect formation. Eclipses will carve paths across entire continents. The moon will transform from silver to blood red, then swell to its most magnificent size. Some of these spectacles will not grace our skies again for another 20 or 30 years. Here is what makes this year truly special. You do not need expensive telescopes or advanced degrees to witness these wonders. Many events unfold right before your naked eyes. From January to December, each event builds upon the previous one, creating a 12-month journey through celestial mechanics. You will see darkness consume the daylight sun. You will watch planets align like cosmic soldiers. For photographers, this year offers once-in-a-generation shots. For beginners, it is the perfect classroom where the universe itself becomes your teacher. But here is the question: why now? Why has the universe chosen this particular year to unveil so many secrets at once? The answer lies in orbital mechanics, in gravitational dances that began billions of years ago, all converging into these 12 remarkable months. Every eclipse, every alignment, every supermoon tells a story of cosmic precision. Ancient civilizations would have called this a year of omens. Today we call it a year of opportunity. This is your invitation to look up and witness something that transcends ordinary life. What begins with Jupiter in January will end with the moon in December. Are you ready? The cosmic calendar opens with a giant. On January 10th, Jupiter reaches opposition, a celestial configuration where Earth positions itself directly between the gas giant and our Sun. This geometric alignment transforms Jupiter into the brightest, largest object in our night sky after the moon. But what does opposition actually mean for us? Imagine three dancers in a cosmic line: the Sun, Earth, and Jupiter, perfectly aligned across millions of kilometers of space. At this moment, Jupiter rises as the sun sets, remaining visible throughout the entire night. The planet appears 30% brighter than usual, outshining nearly every star in our sky. Here is where it gets fascinating. Even simple binoculars reveal Jupiter's 4 Galilean moons, the same moons Galileo observed 4 centuries ago, the discovery that shattered our Earth-centered view of the universe. Through modest telescopes, you can witness the dark and light cloud bands swirling across Jupiter's atmosphere, storms larger than our entire planet. No advanced equipment required for basic viewing. This is backyard astronomy at its finest. The giant planet hangs in the sky like a cosmic lighthouse, calling out to anyone curious enough to look up. But opposition carries deeper significance. It marks the point where Jupiter and Earth are closest in their orbital dance, a moment of cosmic intimacy between two worlds separated by over 600 million kilometers. Why does this matter? Because it connects us to the ancient practice of celestial observation, reminding us that the same mathematics predicting Jupiter's position tonight guided sailors across oceans and farmers through seasons. This is not just stargazing. This is witnessing the clockwork precision of gravity itself. As Jupiter dominates our January skies, it poses a question. If one planet can command such presence, what happens when 6 align? Jupiter's solo performance was merely the opening act. February delivers something astronomers wait years to witness: 6 planets appearing in alignment across our sky. Mars, Jupiter, Saturn, Venus, Uranus, and Neptune arrange themselves in a celestial formation known as a planet parade. But here is what most people misunderstand. These planets are not truly lined up in space, like beads on a string. Instead, from our perspective on Earth, they appear strung across the ecliptic, the invisible highway that marks the sun's path through our sky. This is an illusion of geometry, a trick of perspective that reveals the elegant flatness of our solar system. Just after sunset, turn your gaze toward the horizon, and you will see them. Venus blazes brightest, impossible to miss. Jupiter follows with its golden glow. Mars adds its rust-colored light. Saturn sits more subtly, requiring patience to spot. Then come the challenge planets, Uranus and Neptune. so distant and dim that binoculars become essential tools. Why does this happen so rarely? Each planet orbits the Sun at different speeds, like runners on tracks of varying lengths. For all six to appear in the same region of sky demands a cosmic choreography of orbital mechanics. The mathematics behind this alignment stretches back to Kepler's laws, to Newton's gravitational principles, to the very forces that shaped our solar system 4.6 billion years ago. This moment offers something profound, a single glance that spans from the inner rocky worlds to the outer ice giants, compressing billions of kilometers into one sweep of vision. Ancient astronomers would have recorded this in stone tablets. Today, wide-angle cameras capture what our ancestors could only imagine. But the real question emerges: if gravity orchestrates such precision with 6 worlds, what happens when our moon steps into Earth's shadow next month? The alignment you witnessed in February was preparation for something more dramatic. On March 3rd, the moon performs a vanishing act that has terrified and mesmerized humanity for millennia. A total lunar eclipse unfolds as our moon passes directly through Earth's shadow, transforming from brilliant silver into deep crimson. This is the blood moon, and the physics behind it reveals something beautiful about our atmosphere. When Earth blocks sunlight from reaching the moon, you might expect complete darkness. Instead, our atmosphere bends and filters the sun's light, scattering away blue wavelengths while allowing red light to curve around Earth's edge and paint the lunar surface. The same phenomenon that creates red sunsets now projects onto the moon itself, turning our celestial companion into a glowing ember suspended in space. Unlike solar eclipses that demand protective equipment, lunar eclipses are completely safe to watch with naked eyes. No filters, no telescopes required, just your vision and clear skies. The event lasts several hours, giving you time to witness each phase as Earth's shadow slowly engulfs the moon, holds it in darkness, then releases it back into sunlight. Observers across the Americas and East Asia will see this transformation unfold. Ancient cultures interpreted this event as cosmic warfare, as dragons devouring the moon, as omens of catastrophe. Today we understand it as orbital geometry, yet the spectacle remains equally powerful. Here is what makes this eclipse remarkable. It connects you directly to the three-body problem of celestial mechanics. The Sun, Earth, and Moon must align with mathematical precision for totality to occur. The Moon's orbit tilts 5 degrees relative to Earth's path around the Sun, meaning eclipses happen only when the Moon crosses this plane at exactly the right moment. This is not random. This is predictable celestial choreography. As darkness claims the Moon, ask yourself, what happens when the roles reverse and the Moon's shadow falls on Earth? The Moon that turned red in March now returns with a different kind of rarity. On May 31st, we witness what astronomers call a blue moon, the second full moon occurring within a single calendar month. But here is the paradox that confuses most people. The Moon does not actually turn blue. The name itself is a linguistic accident, a phrase born from folklore that somehow embedded itself into astronomical terminology. So why does this matter? Because it reveals the fundamental mismatch between human calendars and celestial cycles. Our months average 30 or 31 days, yet the lunar cycle from full moon to full moon spans only 29.5 days. This mathematical discrepancy means occasionally, rarely, a calendar month can squeeze in 2 complete lunar cycles. The result is what we call a blue moon, happening roughly once every 2 to 3 years. The phrase "once in a blue moon" captures this rarity perfectly, describing events that occur infrequently but predictably. When you look up at the blue moon on May 31st, you are witnessing calendar mathematics playing out in the sky. The moon appears no different than any other full moon, yet it carries cultural weight that transcends astronomy. Folklore and myths have woven themselves around this event for centuries. Some traditions claim blue moons amplify magical properties. Others see them as moments of reflection and completion. Modern skywatchers appreciate them for practical reasons. Blue moons create exceptionally bright nights, perfect for lunar photography and extended observation sessions. The increased brightness comes from the moon's fullness coinciding with relatively clear late spring skies, in the northern hemisphere. Tides also strengthen slightly during full moons, and a blue moon is no exception. The gravitational pull that creates ocean tides operates identically whether the full moon is the first or second of the month. But beyond the science and the terminology, blue moons remind us that time itself is a human construct imposed on natural rhythms that care nothing for our calendars. As May closes with this calendrical curiosity, June approaches with a visual spectacle that needs no special name to captivate. Two worlds converging in apparent collision. After months of celestial events spread across the sky, June brings two titans together in apparent collision. On June 8th, Venus and Jupiter engage in what astronomers call a conjunction, appearing so close in the evening sky that they almost seem to merge into a single brilliant point of light. This is optical illusion at cosmic scale. In reality, these worlds remain separated by hundreds of millions of kilometers, but from our earthly perspective, they align along the same line of sight. Venus, the brightest object in our night sky after the moon, pairs with Jupiter, the second brightest planet, creating a spectacle visible to anyone with clear skies. No equipment necessary. Just look west after sunset, and you will see what appears to be a double star blazing with unusual intensity. What makes this conjunction special is the closeness. Venus shines with reflected sunlight, bouncing off its thick sulfuric acid clouds. Jupiter glows with light, reflected from its hydrogen atmosphere. Together, they outshine everything except the moon itself. This conjunction demonstrates that despite the vast emptiness of space, gravity and orbital mechanics create moments of apparent intimacy between worlds. Perfect for phone photography, a favorite among stargazers worldwide. As these two planets dominate the evening sky, a question emerges. What happens when the moon positions itself between Earth and the Sun with such precision that day transforms into night? The question posed in June now receives its answer in the most dramatic way possible. On August 12th, the moon slides directly between Earth and the Sun, casting a shadow that plunges daylight into darkness across Spain and Iceland. This is a total solar eclipse, one of nature's most profound spectacles. The path of totality stretches only about 200 kilometers wide. Step outside this narrow corridor, and you witness only a partial eclipse. Stand within it and experience something extraordinary. The sky darkens as if someone dimmed the universe itself. Temperature drops suddenly, sometimes by 10 degrees. Birds return to their nests confused by false twilight. Animals exhibit behaviors normally reserved for dusk. Then comes totality. The moon covers the sun completely, revealing the corona, the sun's outer atmosphere invisible during normal daylight. This ghostly halo of superheated plasma extends millions of kilometers into space, visible only during these rare moments. For maximum 4 minutes, you stand in the moon's shadow experiencing what ancient peoples interpreted as cosmic catastrophe. By cosmic coincidence, the sun is 400 times larger than the moon, but also 400 times farther away, making both appear identical in size from Earth. Europe has not witnessed a total solar eclipse of this magnitude in 27 years. Millions will travel to Spain and Iceland because this alignment will not repeat in these locations for decades. After darkness consumes day, what happens when the moon itself becomes the final spectacle? The moon that created darkness in August now returns as the grand finale, swelling to its most magnificent size of the entire year. In December, our celestial companion reaches perigee, the closest point in its elliptical orbit around Earth, coinciding perfectly with the full moon phase. This creates what astronomers call a supermoon, and this one claims the title of largest and brightest for all of 2025. The moon's orbit is not a perfect circle, but an ellipse, meaning its distance from Earth varies throughout each month. At perigee, it closes to about 356,000 kilometers. This distance translates to a 14% increase in apparent size and 30% increase in brightness compared to when the moon is farthest. The effect becomes most dramatic when the supermoon rises near the horizon, appearing absolutely massive and dominating the skyline with golden light. This supermoon creates stronger ocean tides than normal full moons. Coastal areas experience higher tides by 30 to 50 centimeters more than average. For photographers, this offers the perfect closing shot for a year of celestial documentation. As this supermoon rises in December, it bookends a year that began with Jupiter in January. 12 months of cosmic clockwork culminating in this final display. What did this extraordinary year teach us about our relationship with the cosmos above? The journey from January to December reveals something profound about this year. 2025 represents a convergence of multiple rare celestial events compressed into 12 months, a cosmic alignment that astronomers recognize as exceptional. But what makes a year truly remarkable? The answer lies in diversity, accessibility, and rarity combining in ways that happen perhaps once in a lifetime. Consider what unfolded. Planetary oppositions and conjunctions showcasing orbital mechanics, eclipses demonstrating three-body gravitational dynamics, and lunar events revealing elliptical orbits. Each event told a different chapter of the same story about predictable chaos and gravitational forces shaping everything from tides to planetary positions. For beginners, 2025 provided the perfect gateway. Many events required no equipment beyond naked eyes and curiosity. This accessibility democratizes astronomy and deepens public connection to science. For experts and astrophotographers, this year offered documentation opportunities that will not repeat for decades. The total solar eclipse alone justifies international travel. These events spread perfectly across the calendar, maintaining interest throughout the year. Public interest in space surged accordingly. When people witness eclipses or alignments, they ask questions and feel connected to something larger. This year transformed casual observers into dedicated sky watchers. The universe feels more alive because we paid attention. What changed was human awareness, our collective decision to look up and witness the cosmos. If 2025 taught us to see the universe differently, what happens when we carry that perspective forward? The perspective gained from 2025 carries forward into every year that follows. This was not just a year of astronomical events, but a masterclass in celestial mechanics, demonstrating that the universe operates with mathematical precision stretching back billions of years. Every eclipse, every alignment, every supermoon emerged from gravitational forces established when our solar system formed 4.6 billion years ago. The events were spaced perfectly across months, creating natural rhythm from January through December. Each moment told a story of motion and gravity, of worlds bound by invisible forces. For anyone starting their journey into astronomy, this year proved the barrier to entry is simply willingness to look up. The equipment requirements ranged from nothing to simple binoculars. The sky became a live science show accessible to anyone with clear weather and curiosity. Some moments will not return for decades. The total solar eclipse will not grace Spain and Iceland again in our lifetimes. This creates urgency, reminding us that cosmic opportunities have expiration dates. Nature's biggest light show costs nothing. The universe performs for free, asking only that you pay attention. As this extraordinary year closes, the message becomes clear. The universe continues performing whether we watch or not. The only variable is human attention. Look up, the universe is performing. All you need is curiosity and clear skies. As we step into this year, just remember, the universe is still full of mysteries we haven't touched yet. From mind-blowing space events to things that'll make you question reality, this year is going to be wild. Stay curious, keep looking up, and get ready, because some insane space videos are coming your way very soon. So yeah, new year, new orbit, new mysteries. Happy New Year.